students, this is Ms. Cave with a lesson on determining side lengths and angles of quadrilaterals. Okay, so this is Virginia SOL 7.16b, and I know that some quadrilaterals have angles that are congruent. That's the first thing we're going to look at. We're going to look at congruent angles just like we did at the beginning of class today. Because we know that angles are congruent, we can find missing angles. We can find the angles that are congruent to the others to get their measurements. So for example, I know that a parallelogram has two pairs of congruent angles. I know that a square has four congruent 90-degree angles. I also know that a rhombus has two pairs of congruent angles. So if I know one of the angles, I can figure out the rest. So our first thing we're going to look at is determining angles, missing angles of quadrilaterals when we know the properties of the shapes that have congruent angles. So we're going to look over here. And we have all of these shapes that have congruent angles. And we're going to use what we've learned about their congruency to find the missing angles. So this shape here is a parallelogram. And we know it's a parallelogram because it has two pairs of parallel sides. And it also has two pairs of congruent sides. We're going to talk about side lengths in a minute. And it also has two pairs of congruent angles, excuse me. Okay? So now what I'm going to do is I'm going to use what I know about the congruent angles to find the missing angle measurements. You can see that this is labeled 100. The opposite angle to 100 is going to be congruent because we know that's true about parallelograms. So if this angle is 100 degrees, this angle over here is also 100 degrees. Same thing goes with this one here. The opposite angle here, which I should have done 2 because it's a different angle. The angle that's opposite to this angle, which is across the shape, is also going to be how many degrees? 80. Okay, so that's pretty easy. You're just looking for the opposites and finding that they're congruent, and they're going to be the same measurement. The next shape we're going to look at is a square. I know that the square has four congruent angles. I also know that, so it has four congruent angles. I also know that it has four right angles. So using either one of these, I can determine that the other three angles are how many degrees? 90. So these are all going to be 90 because of those things that I know. Make sense? Make sense? Okay, thank you. All right, so let's look at this shape here. What is this shape? It's a parallelogram. It's a special parallelogram. What is it? It's a rhombus. I know a rhombus has two pairs of parallel sides. I know a rhombus also has two pairs of congruent angles. Opposite angles are congruent. So this angle here is going to be congruent to this angle here. And this angle here is going to be congruent to this angle here. They're across from one another. They're opposite angles. And I know that opposite angles are what? Congruent. So if this angle here is 103 degrees, what would be the measurement of this angle? It would also be what? 103 degrees. Okay. Over here, if this angle is 77 degrees, what would be the measure of this angle? 77 degrees. So far pretty easy, right? You're just looking for opposite angles. We don't even need to look at the totals yet because we know just from the properties of the shapes that if I know one opposite angle, I also know the other. Okay, that brings us to our trapezoid. And our trapezoid, this is a special type of trapezoid. What kind of trapezoid is this? It's an isosceles. It's an isosceles trapezoid. Isosceles trapezoids have one pair of congruent sides. Okay, so for isosceles trapezoid, this angle here is actually going to be congruent to this angle here. You see that? They're right next to each other. And this angle here is going to be congruent to this angle here. So it's not opposite. It's going to be adjacent, or angles that are right next to each other. So this, if this is 110, what's this? 110. But only for isosceles trapezoids does this work. And then if this is 70, what's this? 70. So it's not opposite angles this time. It's like next door neighbors. They're right next to each other. Angles that are next to each other. And then I should probably make an extra line because these are not, those are different than the ones on top. Okay, and then the last one, what shape is this? Rectangle. I know a rectangle, just like a square, has 4 congruent angles and 4 90-degree angles. So if this is 90, what do I know is true about the other angles? 90. So that's how you find missing angle measurements when you just look at the angle properties and you're given like 2 of the angle measurements. Okay, now we're going to look at the next part, which is I know that the sum of the angles for any quadrilateral, we looked at this today when we cut off the corners of the parallelogram and we matched them up, and we said that the sum total of angle measures for any quadrilateral is going to be how many degrees? 360. So using that, we're going to fill this in with 360 degrees. So if I know one or more angles, I can figure out the missing angle measures. So looking inside, first I have a trapezoid, isosceles trapezoid. Okay, if this angle is 65, what would this angle be? It's also 65. Remember, the ones right next to each other are congruent. But now what I'm trying to figure out would be this angle and this angle. Okay, I'm not given either one. So I have to use what I know about the sum of angle measures. What's the sum of angle measures for this shape? 360. So I know the sum is 360. So what I have to do is add the 2 angles that I know. So I'm going to take 65 plus 65, and I get what? 130. I subtract 130 from my total to see how many degrees I have left, and what do I get? 230. So does that mean that this angle is 230? No, there's 2 of them, so you have to do what? Divide by 2, and then you get what for these angles? 115 each of them. That's good. You guys caught on quickly. That's awesome. All right, so if we look at this shape over here, Is this a trapezoid or parallelogram or anything? It might be a trapezoid, but look how only one angle measure is missing. How could I figure out that one missing angle measure? Add them all up and do what? Subtract from 360. So what I can take is, I know my sum is going to be 360. So what that means is I can add 83 plus 124 plus 62. And what do I get? If I add up all those angles, just you can use your calculators. Some of you have them out. Who's got it? 269. So that means that this is 269. And then I'm going to subtract 269 from 360. And then what do I get for the missing angle measure? 91? You guys confirm that? 91 degrees. See that? So this angle over here, because I added these together and then I subtracted from 360, I determined that this was 91 degrees. Make sense? So now we can try the next one. This is very similar. We're going to add up, again, our 89 plus 109 plus 68. If I add all those together, what do I get? 266. So this time I'm going to take 360 and subtract 266. And then what would this angle measurement be? 94? 94 degrees. Okay? Now the last one's a little bit trickier because what shape do I have? It's not a rhombus, parallelogram, and I know that this angle is 40. So if that angle is 40, what is this angle going to be? 40, because opposite angles are congruent. Now I've got to figure out this angle and this angle. And how can I do that? Adding them together. So I get 40 plus 40. So I get 80. And what do I do with the 80? I take 360. I subtract 80. And I get what? What? 280. So does that mean that that's 280 degrees? No, I have two angles that are congruent. So I simply divide them by 2, and what do I get? 140 degrees. So over here we have 140, 140. That doesn't show up very well, but you can see it. 140 and 140. Okay? Now the last thing that we're going to look at is missing side lengths. Over here, I know that some quadrilaterals have opposite side lengths that are congruent. Okay? I know that sides are congruent, so I can get missing side lengths. So now we're moving away for a moment from angles to look at side lengths. And what I would like you to do is go ahead and see if you can figure out these missing side lengths based on the properties of these shapes. So see if you can figure out all the side lengths of these shapes by knowing what they are, and that's what we'll start with tomorrow. And that's our lesson on missing side lengths and angles of quadrilaterals.